show an example of analytics in action and the kind of work that is how you would actually do this kind of work in the real world. So I'm using a program here called Jupyter, and I'm using a programming language called Python. And basically what this allows me to do is to go through and bring in my data set just the way that you would in Excel, except I'm opening it here in Python. I can see kind of the values we have here. It looks just like Excel. But the data set's kind of dirty, and so I need to go through and change some of the data types and remove some things like dollar signs and commas in order to be able to actually do the analysis. So that's the kind of stuff that you can do in Excel, but it's a little tricky. Then I'm asking to see a box plot. You can see I type in the request for the box plot and it shows below. Obviously not a very interesting box plot, so I can just do the same thing again and see a version where it's just the values that are equal to or less than 300. What's nice about Python is that it's very fast and it keeps track of all the things I've done, so this is easy for me to hand off to someone else and they can see exactly the steps I took in my analysis. So we can do a box plot, same thing, change to a histogram. Now I can do two box plots, so I can compare this group, which is not a superhost, and this group that is a superhost. And I can do a pivot table, just like we would do in Excel, where I can see the average price here, if you're a superhost or not, and then take those values and compare them using a t-stat. We can see with the p-value that there is not evidence to conclude that they're different. We would fail to reject the null hypothesis. Here, there's not evidence to show that they're different. The data set we're looking at is 23,000 rentals available in Toronto, Canada on Airbnb. So we can see how the price of those breaks down based on the type of bed you offer. So airbed, couch, futon. And what I want to understand is what's the money I get to charge based on the different type of bed. And so I'm going to do an ANOVA to see if there is a difference. Now we can see yes, my F value is sufficiently big, or my p-value is sufficiently small that there is a difference in the means. And then this is the regression output. So I can see the R squared, adjusted R squared, F statistic, same thing that we looked up there. But what's more useful are these values here. So my coefficient. And there are 4 listed here: couch, futon, sofa, and bed. And there are 5 things here. Airbed is the first one. So what this is showing me is the price relative to airbed. So airbed is the base price. This means that a couch rents for $115 more than an airbed on average. You can also see the t-stat and our p-values. None of these are statistically significant. So this is not a particularly good regression, but what it's trying to do is show how much more I would charge if I had a different kind of bed. So another thing I might want to look at is the different amenities that are provided. So as a business owner, I can decide which amenities to provide myself and which ones are the most valuable. So I wanted to look specifically at Wi-Fi, internet, cable TV, dog, and cat. And I create new columns with those data. Right? It takes the value of 1 if that property has Wi-Fi, or 0 if it doesn't have that amenity. And then I wanted to look at whether or not having a dog or cat makes a difference. So again, I'm going to pivot the data to look at, these are people who allow neither cats nor dogs. The average price is $144. If you allow cats but not dogs, the average price is $97. If you allow dogs but not cats, it's $123. And if you allow both, the average price is $136. So then I just do the same thing looking at these contingency tables. I can see what's interesting is that only 87 out of 22,000 properties allow both dogs and cats. So that is 0.003% of the overall data set. So there's a very small number of them that allow it. Now I want to see if what's the value of allowing dogs and cats. So I would do a regression model again. I'm going to take my price, I'm going to multiply it by this, whether or not you have a dog or a cat, and it's going to give me these values. So if you have neither dogs nor cats, it's $144, and that's something that we actually established. A little up here, $144. Okay, if you allow neither dogs nor cats. If you allow just cats, then you would subtract $46. So allowing cats but not dogs actually decreases how much you can charge by $46. Or if you have a dog, you decrease it by $16. But actually, if you're in the small group where you have both dogs and cats, then you actually get to charge a $54 premium. So you get to charge more. Again, our values are not really statistically significant here. It's not a very strong regression, but it does show that we're trying to understand a relationship between these things so that we can make better decisions on what to offer. This next set of analysis goes through and does sentiment analysis. So it looks at the words that are used to describe each property and then rate them on a scale from -1 to +1 on how positive the description is written. And then we use that to predict price. And we find that the more positive your write-up is, the more you can charge. Finally, we look at the types of rooms that are available. So in this data set, you can rent the entire home, you can rent a hotel room, private room, or shared room. And we do the same type of analysis to see what's the value of each. So compared to the entire house, if you have a hotel room, then it's $53 less than the entire house. A private room is $107 less than the entire house, and the shared room is $126 less than the entire house. I'm able to do some more sophisticated things here, just kind of switching the type of regression around, doing a lot more variables here, and even more. The point being, now I can start to find relationships between bed type and home or type of property, and use that information to try and understand if I'm going to buy a property, what type of property should I buy, and then what should I put inside. So this is an example of the type of analysis that you can do. This is all very simple using Python, and it's doing the same kind of analysis that we're doing in Excel. The difference is this structure allows us to see very clearly what's happening as we go through.